class is going to be about a more deeper introduction to packet tracer and how I would say configuring devices works over there. Now, as you can see my screen over here, we did discuss about how to configure the basic switches, right, and connect them by using some cables, okay, with the devices. And the topology did seem like this. So we went over here into the section and we went onto the switches and then dragged the switch for us. And then we had a couple of PCs with us. Like this. And then we went into the devices and configured some IP addresses like 192.168.1.1 and then provided the IP of 192.168.1.2 over here. I'll just copy that and then paste it in next devices like 1.3 and tab. And if we connect them together by using some cable like this and then try to send some messages from first PC to other PCs. And you can see that's how. Okay, the switch is still starting up. You can see that. And if I click on this fast forward time, it will take the simulation and now it's all green. So if I send a message now from here to here, it's successful. So that's exactly how it worked. Right now, how we're going to move further with this is we will just build up a local area network connection by taking a router with us. So what we are going to do is we have these two PCs, right? But and we do not want these devices to be here. So I'll just delete them. And I will take new devices, like let's say a new switch and then a new router. So the router that you need to select for building up a topology, you can go up into this router section and then you need to select PT router. Okay, this PT router basically is just a basic router that gives you all the ports that you will need. So if I hover over my cursor, it gives you the analysis that it has a couple of fast Ethernet ports and a couple of serial ports, and that's all we need. Okay, otherwise all these different models have some other ports according to their model number, but this router gives you the basic necessary ports that are available there. And you can see that PT router over here and you can select that accordingly. Makes sense? So and then I will just connect them like this. And now we are going to use a network called 192.168.1.0. Now we saw how you can manually, I would say, create a network or a local area network without considering switch over there. Or sorry, without considering a router over there, right? And any configuration would not be needed over there. But in order to configure devices where you, let's say you have, I would say 100 PCs or 200 PCs, it will be kind of difficult for you in order to ping to those particular devices by like for the configuration of IP address, like going down to each and every PC and configuring IP address and password, or I would say or subnet mask doesn't really seem a good option. So for that, what you can do is there is a protocol called DHCP, right? But before that, let's see how you can make the router as part of your network. So you can see that we are connected with FA0/0, right? That's basically the interface that we have for router. And then the switch is connected with that particular router by using FA0/1 interface. So this FA0/0 interface is also participating into 192.168.1.0 network. And as we have talked about, that switches do not need to be configured with any IP address as it has multiple ports. You see that? So you have around 24 fast Ethernet ports and 2 gigabit Ethernet ports. But these particular ports doesn't need to be configured with IP addresses, as switches, layer 2 switches doesn't work with IP. But routers FA0/0 needs to be configured with an IP address. And what that IP address would be? That will be the first IP address. Usually, the best design practices say that keep the first or last IP addresses as the IP address of your router's interface. Okay, and the same IP address can be used as gateway. But we'll be discussing about what gateway is and how it works. That's none of our concern as of now. And how to configure those devices. So for that, you can click on that particular router. I'll just take the topology sideways, and then once this window pops up, after clicking onto the router, you can go to CLI. Okay, so there is this physical window, there is this config window, there's this CLI window and attributes window. So for physical window, you can see that all these modules are here, and these are all empty slots in which the interfaces can be installed on. So like this is kind of one of the interface that has installed, and that's another interface that has been installed. Okay, so these are like fast Ethernet and serial ports. So you see this CGE. If I want more of this PC, I can just put up that, drag that module and place it over here, and it will be installed. But for that, the device needs to be off. You see, cannot add a module when the power is on. So you need to turn it off from here. You can see that this is basically the switch. So you can power this off. Now it's off, right? And you have this fast Ethernet port. So you can power that particular off. You can slide it across and drag this particular port and place it over here like that. And you can remove it like this. That's how we do it. And once you're done, you can just turn on the router again. And that's on. You can see the green sign. And then you can go into the CLI window, which is command line interface, where all the configuration happens. Make sense? Now over here, as you guys are familiar, that this is going to be Cisco's internet networking operating system, the Cisco Ios, the image that all the devices of Cisco uses, right? And as soon as you boot that particular device up, the operating system will ask you, if there is no configuration found, that would you like to enter into the initial configuration dialog. Cool. And what you're gonna say over here, you're gonna say no. So you will click on the no window, or you will type down no over there into the CLI and say okay, or hit the enter button. Right, and then I can hit enter, like enter or return key for how, like you can enter it for how long you want. Okay, and what we need to discuss now is there are, I would say, three modes that you need to know about the Cisco CLI. So the Cisco iOS modes, that's what we need to learn about. So Cisco has three modes. First is called as user mode, and user mode is indicated with greater than sign. The second mode is enable mode, which in book we call it as privilege executable mode or privilege exec mode. And that particular mode is highlighted with hashtag. Okay, you can get to know about that with the hashtag. And the third mode is global config mode. And that particular mode can be highlighted with config hash. You see that? So user mode is basically used for troubleshooting something, right? And then enable mode is basically used. So there are three modes, that's user mode, enable mode, and global config mode. So user mode can be seen by looking at the greater than sign. Okay, and do not do the lab as of now. I will give you time to do the lab. Okay, please pay your attention now. So you can see that in the CLI, The user mode is the first mode. So this is basically the name of the router, that's router itself. And then the greater than sign is basically the mode type that you can see. So currently we are into the user mode, and the user mode is basically used for troubleshooting purposes or verification purposes. And then from user mode, you go into the enable mode. So this is kind of hierarchy, I would say. From user, you go into enable, and from enable, you go to global config. And global config is basically a mode in which you can troubleshoot everything. So from user mode, which is a default mode, you can go into enable mode by typing down enable. Okay, and you see that the mode of this particular router changed, and you are currently into privilege executable mode or enable mode. And then from this particular enable mode, you can go into global config mode by using configure terminal. Okay, and hit enter, and you will be into global config mode. And global config mode is basically the mode in which you can do all type of configuration on that particular device. Makes sense to you? These are the three modes that you have. So we will be working in global config mode most of the time. And then to do the verification, you can go back to the privilege executable mode or enable mode, and check your configuration if it's working or not. And if you want to go back, then exit is basically the command. So you can use exit and you will be out of global config, and you can go into the user mode again. There is no direct jump from user to global config. Okay, you need to go to enable first, and then you can go into global config by using configure terminal. Make sense? Just like that, let's say we want to now change the name of the router. So how do you change the name of the router? You can take let's say that we have freshly started this particular router, and that's our user mode. So you go to enable, and then you go to configure terminal, and then you say host name R1, and that's what the name we need to give it. Let's say R1 PyNet. Good. And then you can, as I hit enter, you can see that the name of the router has been changed to R1-Python now. Correct? And we are still into the global config mode. And that's exactly how you configure, I would say, name on your router. Okay, you can rename your router by giving a command called host namespace, whatever name you want. You cannot use spaces in your names, so you can use however special characters for your names. And then you can take an exit, and then exit, and everything will be done. Now, the next task over here is to configure IP address on the interface of FA0/0. So you can see that there are some green lights, right, between the connection that have been made with the switch and the PC. And over here, you can see red lights that you are there, right, between the router and the switch. These connections are highlighted with red dots. So what does this red dot signify? It means that the connection between the router and the switch is turned off. Enable difference between enable and global config is that in global configuration mode you can configure it. You can configure the parameters on your router, but with enable mode you cannot do that. Enable mode is basically used for verification purposes. Cool. And now, as we are into this, you can see that there are different connections. Some connections are green and some connections are red. So by default, whenever you use any interface of the router, this particular router's interface is not on by default. Okay, you need to turn that particular interface on by manually intercepting in it. And then you need to configure IP address on that to make it communicable. Okay, if I show you the highlight or the statistic, you can see that FA0/0, FA1/0, or fast Ethernet 0/0, 1/0, SA2/0, these are all the name of the interfaces that the router has. Okay, and you can see just next to that there is a column which says about link, and everything is down. That means that there is no power in these interfaces. Cool. And also the next column says IP address. So IP address is not configured. So what we need to do, we need to go in that particular interface, right? And then we need to turn that interface on, and we need to configure an IP address on that particular interface. And what IP address are we going to use? We cannot use 1.0. We cannot use 1.1 or 1.2, right? Can we use that? Yeah, okay. So we can use 1.1 and you can use 1.2. Cool. 1.255 is again not usable, okay, because it's gonna be the broadcast ID. But we can use 1.1. You can use 1.2, 1.3. We cannot use 1.0 and 1. I would say 255. That's gonna be the network ID and broadcast ID, the first and last. But the best practice says that it's always better to use the first usable IP address as the IP of your router. So how are we going to do that? We will go to the router, and then we will select what interface do we need to turn on. So we will go to enable mode, we'll go to conf t, and then we will say interface FA0/0. Good. And after going into that particular interface, I would say no shutdown in order to turn that interface on. Okay, and as I hit no shutdown, you see that the light became green now, and the switch is also starting the interface. Makes sense. Switch does take some time to turn on the interface over there, but yeah, no shutdown, and that's how you turn on the interface. So the first command was go to the global config mode, and then select interface FA0/0, right? And then you can use no shutdown command in order to turn the router on. We use no shutdown because the interfaces of these like the router is on, it's off. By default there is no power, so that's why we need to turn each and every interface on. As we are only using the FA0/0 interface of the router, you can see that that's the only interface that we have turned on. And then if I show you that, you can see that the link is now up for FA0/0. And but the IP address is still not configured over there. That's just, we just turned on that particular interface. So in order to configure the IP address, you can just stay in that interface config mode, right? And you can use a command called IP space address space 192.168. What IP address are we going to use? 1.1 space, we're going to use the subnet mask 255.255.255.0. That's what the subnet mask is going to be. And we say enter over there, and then that's configured. The IP address is configured. Makes sense. So that's exactly how you are going to configure this. Yeah, every port on switch is by default on. That's correct. But on router we have to do it manually. Yeah, that's correct. So the commands that we used is we used enable in order to go to the enable mode. Then we used conf t, right? And then after that, we went into the interface, that is interface FA0/0. And then you go to, you use a command called no shutdown in order to turn on that interface, right? And then you basically configure an IP address by using IP space address space 192.168.1.1. And along with that, you can use the subnet mask that you want to configure for. There is no GUI configuration, I would say. There are shortcuts that are available like these, but that's not going to help you to learn anything, because on real devices there will be no graphical user interface. You just need to learn about the commands that Cisco has. Cool. So go ahead, try to configure this setup over here, okay, by using the commands, and you are supposed to write down the commands that we are using. Okay, so go ahead, configure this topology, and now you can see that as we have the IP address configured, we can go ahead and configure another IP address on our desktop and IP config and say 192.168.1.2. And as we have our gateway ready over here, FA0/0, that's going to be the address of our default gateway. So we say 192.168.1.1. The router's IP address will be the gateway of that. But still, we do not need the gateway as we are not going from one network to other network. We are still in same network. But let's just configure the gateway over there. And then I will come back on the second PC and say 192.168.1.3. And the gateway will be the same thing. 192.168.1.1. Right? And then close it and see if the communication happens from here to here successful. Are we able to reach out from PC to router? Successful. And from router to second PC, that's first is failed but successful. Make sense to you? So that's the small lab that you need to do. Go ahead and try to do this. Okay. Cool. We will move ahead. Now the next lab is going to be about how you can configure DHCP server on that router. Right? And now there are a couple of other features as well of Cisco Ios. So when we were using that, Cisco kind of identifies the shortcuts as well of the commands that you use. So instead of using the entire enable thing, you can just use en, right, and hit enter, and it will detect that. Instead of using the configure T, you can just use conf for configure and T for terminal. And once you hit that, it will kind of also detect that. Cool. In order to go to the interface, instead of saying interface FA0/0, you can altogether just say int for interface and FA0/0, and you will be inside of that interface. And to configure IP address, you can just say IP add and then type down whatever IP that you want, and that will accept that. Also, you can use commands like you can use commands by pressing the tab as well. So if you want to go into conf t, you can just say con and press the tab button, and it will automatically complete that. The tab will not work if there is ambiguity between these two commands. Okay, and if there is no ambiguity for the command that you're using, it will just auto complete that. Like for T, I'm just using T and press the tab button, and it will automatically complete that to terminal. So that's something that you can use as well. Right, so I'll introduce you with the shortcuts of Cisco's operating system, okay, as we move on in this particular course. And after that, con is basically not a without ambiguity command. There is ambiguity for con, so you can use con and press a question mark after that, and over here con question. You see there are two commands that starts with con. One is configure, the other one is connect. So that's why tab doesn't work. You can use question mark for getting to know that what all commands can be used. Yeah, so you can use question mark in order to get to know the IP addresses over here, and then in order to configure DHCP. So what's DHCP actually? DHCP is something that you can configure for assigning IP addresses automatically to users. Cool. So let's say that we have these two PCs and we configure the IP addresses manually on these. But if you have multiple IP addresses, or if you have multiple PCs that needs IP address, going over to each and every PC and assigning IP address is not a good idea. Correct? So for that, you can use something called DHCP. And DHCP stands for Dynamic Host Configuration Protocol. Right? It basically assigns IP addresses automatically. So in order to configure what this does, there are four packets that it sends. D stands for discovery, O stands for offer, R stands for request, and A stands for acknowledgement. So it sends whenever you kind of send a request for DHCP address, then the PC will send a discovery request and it will broadcast to each and every particular host that is present, right? And then whosoever DHCP server is available, it will kind of, I would say, offer the IP address to the PC, and then the PC can request that I want this IP address to be configured, and with an acknowledgement, the address can be configured on the device. So you see, there are two options that you can use. You can click on the PC and go to IP config and click on DHCP, and everything will be automatically configured. But you need to have a DHCP server in your network, and then only it will work. So how do we use that? We basically configure a DHCP server on our router, right? So you go to the router, and for the commands that we can use in order to configure a DHCP, the first command is you need to create a pool. So we will again go to conft, like configuration terminal, and then we will create a DHCP pool by typing down a command IP space DHCP space pool space. You can name that. I'll just name it as AB. Okay, write down the commands, and then I will provide you time to do the lab. So IP DHCP pool AB, and then the next command is network space. You specify the network ID of the network that you're using. That's 192.168.1.0, right? And then along with that, you also use subnet mask, that is 255.255.255.0. That's what the information is. Network ID space the subnet mask. Cool. And the next command will be in order to provide the default gateway address on the PCs, that will be default hyphen router. Okay, and you can specify the gateway address that you want to be configured as default gateway on the PCs. So you say default hyphen router space 192.168.1.1. These are the three commands: IP DHCP pool and the name of the pool, then network space network ID space the, I would say, subnet mask, and then default hyphen router space the IP address of the router that have been configured on its interface. Correct? And then you can add up new PCs. Let's say this PC has been added, and then I will just connect it, right? And as this is turning on, I will just fast forward it, and the interface is green. You need to make sure that the lines are green so that it can get the request. And then click on the PC, go to desktop, and say IP config. And instead of static, you can click on DHCP, and it's a requesting IP address, and there you go. So the IP address is 192.168.1.4, subnet mask and gateway. Everything is automatically configured. Make sense? That's how you configure DHCP. Do you understand that? Perfect. Go ahead, try to also configure this. Right? These are the commands. Okay. You can ignore these conflict messages as of now. Yeah, you can also configure a DNS server as well. The DNS information can also be provided with DHCP. So, but not a go-to now for now. Just go ahead with these information and we'll be good. Okay. I'll give you 2 minutes of time to do that. The DHCP pool needs to be created so that the router actually knows about how many addresses does it have. We will talk about how to check DHCP pool now. Okay. Can you see my screen now? You guys can just check that if you have IP address 192.168.1.1 over here. Do you see the IP 192.168.1.1 in FA0/0? After that, you can just go ahead and run this command called show run in enable mode. And once you run show run, just check these three commands are configured as just like I have. So the command is show run, and you should see this IP DHCP pool configuration. Perfect. And if these things are ensured, then your DHCP should work properly. Okay, and also the interfaces needs to be green. There shouldn't be any link that is red. So yeah, then that makes your DHCP work. You can just go on to this particular PC and IP config and request DHCP. and it will work 1.5. That's what the IP I got. This can never happen, I would say. So the IP address cannot be 1.0. The IP address would be 1.1. IP 1.0 is a network ID. There are two type of configuration. I will again go ahead and do all the configuration that you need to do, starting from fresh. So you go to enable, then you go to configure terminal, and then you say interface FA0/0, then no shutdown, right? And then you say IP address 192.168.1.255.255.255.0. Okay, this is when we configure IP address of your internet or of your interface. Cool. And then you take an exit from that mode, and then you create a DHCP pool, IP DHCP pool A. Okay, or the pool that I had, AB, let's say, IP DHCP pool AB, and then you say network space 192.168.1.0 space 255.255.255.0, and then you use another command called default hyphen router and 192.168.1.1, and that's all. Cool. That's the command that you need to use. Make sense? Now, this is how you deal with default subnets. Okay, you deal with default subnets on this, and the we are going to move towards a section which is called as VLSM. So I'll stop sharing my screen and I will share my another screen with you. Now, the concept that we are going to discuss is VLSM. And pay your attention that this is kind of a thing that's not usually easy. But if you understand each and everything very well, then you might crack it. So VLSM stands for Variable Length Subnet Mask. Right? Variable Length Subnet Mask. And what does this mean? We learned about subnetting and how it works. So let's say that you kind of build up a network in which the requirement of host that you have differs according to the size of the employees that you have in your different departments. So you have four departments. The first department is sales, and the sales department has a requirement of 120 users. Cool. And then there is another department called marketing, and the marketing department has a requirement of 60 users. And then there is third department called HR, and the HR department has a requirement of 25 users. And then there is also an admin department which has a requirement of 10 users. This is the office requirement that you have got, and you got to build up a topology that works, but your network admin has only provided you a single subnet called 192.168.1.0/24. Cool. That's the only subnet that you have over here. Then, if we build up a topology according to this way, you will have a router over here. That's going to be your R1. Then you will have another router, let's say R2. Then you will have another router, let's say R3, and you will have another router R4. Cool. And then we basically connect it with different switches. So you will have a switch over here. You will have another switch, another switch, and another switch. Oh, no, let's not connect them together now. Okay. This is how the topology looks like. And then the network that you are provided with is 192.168.1.0/24. And you're going to have different PCs that would be connected. The lines indicate the users. So the first network is going to have 120 users, that is for sales. Then you're going to have 60 users for marketing. Then you're going to have 25 users for HR, and you're going to have 10 users for admin. So the golden rule of VLSM is bigger network to smaller network, which means you cannot configure the network that has user requirement of 10 users first and then go to the bigger ones. Do you understand that? So you need to start with the biggest one, that's 120, and then go to the biggest one, and that will be number one. Then number two will be 60. Number three will be 25. Number four will be 10. That's exactly how you go. Okay, you cannot go like this. First one will be this, second is this, third one is this, and fourth one is this. No, not like that. The only rule that VLSM has is configure the biggest network first, and then go towards the smaller ones. So, in order to figure out the, I would say, subnetting for the first network, that is 120 users, you need to do subnetting. And what do we figure out for 120 users? Getting back to subnetting, we are using 192.168.1.0/24 network, right? But as you have a requirement of 120, what's the nearest value into power of 2? That's going to be 128 users. That's going to be the requirement. So writing down the master formula again: 64, 32, 16, 8, 4, 2, and 1. And the values that we used: number of network, number of hosts, subnet mask, and ranges. These are the four things that we use to fetch out. And over here, the priority will be given to number of hosts in VLSM. Okay, it doesn't matter how many network do you have. So you go with number of hosts. And how do you go ahead? The number of hosts, as you need 128, how many bits do we need to keep off? As number of hosts is 2 to the power number of off bits. How many bits do we need to keep off? 7. Correct? Do you all agree that? Perfect. So we will say 2 to the power 7 will be off. That gives you 128 uses. And we are only going to use 120 of that. However, the valid will be 128 minus 2. That's 126. And then ultimately, as we have turned down 7 bits, how many bits are going to be on for number of networks? 1. Perfect. So because 2 to the power number of borrowed bits is what networks sounds like. And that's going to be 2 to the power 1. That will ultimately make 2 networks. And can we say that the first network for 120 users is made up of /25? We can say that it's a /25 network for first network. Perfect. So the subnet mask for /25 can be 255.255.255.128. Any questions? Very good. And then the networks for them will be 192.168.1.0, right? And it will end up on 192.168.1.127. And then we'll have 192.168.1.128 to 192.168.1.255. These are going to be network number 1 and network number 2, okay, for the thing. But we will only use this network, the first network, and we will not use the second network that we have. Make sense? Because we are going to again inherit this network into some other partitions. So we will just use the first network, and that first network is going to be used for the biggest network that we have. So to come up with a solution, the sales department is gonna get 192.168.1.0/25. Good. And then out of the 256 IP addresses we had over here, how many IP address did we use? For network number 1, we used 128 IP addresses. How many IP addresses are still with us? We have 128 more IP addresses. And the next requirement is for 60 users. So let's go ahead and figure that out as well. You guys are getting it now, I guess. So we have a requirement of 60 users. So what's the nearest value that we can come up with in the power of 2? There you go, 64. Good. How many bits can we keep off? 6 bits. That's 2 to the power 6 in number of hosts. That gives you 64 hosts. How many bits do will we keep it on? Perfect, 2. So that's going to be 2 to the power 2, and it's going to be 4. And the subnet mask, can we say that it's going to be of /26 for now? Because we have 2 bits as on. And just for that, the subnet mask will be 255.255.255.192. Exactly. And then where would we start with our network? The network is going to start now at 192.168.1.128, and we're gonna end up at 192.168.1.191. This is the block that we're going to use. Doesn't matter because the first network is already used there. We cannot again start with 1.0 and end up at 63 because the number of hosts is 64. Okay, we're gonna start next to what we have used prior. So we will start with 1.128 and we'll end up at 1.191. Good. Yes, we need to add 64 bits, not the 65. 64, I would say IP addresses and not the bits. Make sense? Okay. So I would say, and this is going to be the network ID, and that's going to be the broadcast ID. Cool. So I can say that the marketing department is gonna get the network of 192.168.1.26. Makes sense? And then the next requirement of us is going to be of 30 users. So for 30 users, and then the next requirement is of 25 hosts, I would say. And the nearest value is 32. Can we say that? Perfect. So we're gonna keep how many bits as off? 2 to the power 5. and the number of network would be 2 to the power 3, that's 8, and it's gonna be /27 now. Good. The subnet mask is going to be 255.255.255.224, and the network and the network that we're going to start up with is 192.168.1.192, and we are going to end up at 192.168.1.223. That's what it's going to be. And then the network that we're going to dedicate for HR is going to be 192.168.1.192/27. This is what we're going to dedicate. Make sense? And for the last network that we have, which is for 10 hosts, you can say that the number of hosts is going to be near to 16. So we're gonna keep 4 bits as off and 4 bits as on. And as we're keeping 4 bits on, 128 plus 64 plus 32 plus 16 makes 240. And the network is going to start up at 192.168.1.224, and it's going to end up at 192.168.1.239. That's what the block size would be. So you can say that we are dedicating 192.168.1.224/28, correct, for the fourth network that goes to the admin department. I hope you all understand that. And that's how you configure variable length subnet mask for a network over here. So we will just go ahead and configure the same, okay, on each and every router that we have over here. I'll just share the screen. Okay, you guys please look at the lab that I'm doing, write down the commands, and then try to do that. If you try to do it parallelly while I'm explaining, you might miss on the concepts that I want to highlight. As I do provide you time, right, to practice. So please. So yeah, I'll just build up the topology, the same topology that we have practiced in our note. So I'll take 4 routers, 1, 2, 3, and 4, and then I will take 4 switches, and then we will also take a couple of PCs. So 1 and 2, 1 and 2, 2 here and 2 here, and then we will just connect them all together. Are we good? Now, the first network over here needs to be about 192.168.1.0/25. Then we have 192.168.1.0/26. Sorry, not 1.0, 1.128/26. Then we have 192.168.1.192/27. And we have 192.168.1.224/28. That's what the networks are that we gotta have. And then after that, we will connect these 4 routers together. But let's just figure out that how fast Ethernet needs to be configured. So I'll go to router 1. Please write down the commands. I strongly advise you guys. Okay, so I'll go to CLI, then say no. Then I will say enable. Cool. Then I'll go to configure terminal and name this particular router as hostname R1. Good here. Then I will go to the interface FA0/0 that we are using and say no shutdown. and provide an IP address of 192.168.1.1 space 255.255.255.128. The cables are connected, you can see them. The routers are not like needed to be connected as of now. Okay, we will connect that later as well. So IP address 192.168.1.1 for the first network along with the subnet mask of /25. Any questions here? Good. Then we will configure the DHCP pool for that. Let's say IP DHCP pool A, network 192.168.1.0, space 255.255.255.128. And then default is 192.168.1.1. Or I would say default router is 192.168.1.1. And that's what the DHCP config will look like. Okay, you need to be sure that you use the correct subnet mask and correct network ID over here. And that's the entire config that you need to do for R1. So I'll again review that. You go to enable conf t, give a name to that router, that's host name R1. Then go to interface FA0/0, no shutdown, and provide an IP address on that interface. That's going to be part of the /25 network. And then you go ahead and say IP DHCP pool A, network this, and then default router. Make sense? Then we will go to the second router, or I will say first we will just check the IP addressing. We'll go to the first PC and see if it works. There you go, 1.2, the same subnet mask of /25 and the default gateway. That's configured. Then I'll go to the second PC and click on DHCP, and it works too. Cool. So yeah, that's our first network configuration. Then we will go to the second router now. We don't need DNS now. Don't worry about DNS. We go to no, say enable config t, and then again go to interface FA0/0, and we configure IP. What network do we need? 128/26. So 128 is going to be the network ID. We'll say 192.168. Okay, we also need to use no shutdown and turn that interface on. And then after that, we will use IP address 192.168.1.129, space the subnet mask of 192. That's going to be for /26. And we hit enter. And then we configure an IP pool, IP DHCP pool B, and say network space 192.168.1. The network ID would be 128 over here. Space the subnet mask is going to be the same, and the default router would have an address of 192.168.1.129. That's going to be the IP address. There you go. Are we good? Enable conf t interface FA0/0, and then IP address, and then create pool, network command, and default router. Yeah, giving host name is kind of skipped by me. So you can take an exit and say host name R2, and we're good. Any questions for R2? Network ID is 128 because 1.0 is the is the network ID of first network now. Every network has different network ID. Good. The network ID for the first network is 1.0 and the broadcast is 127. For second network, the network ID is 1.128 and the broadcast is 1.191. Perfect. Yeah. So that's what our R2 config looked like. Say no. It's just short form. Nothing. No, there's no difference. Okay. I can use like the short form of the command called default instead of using default router. That's all. So we'll say enable, and then I would go to config t. Just like for instead of configuration terminal, I'm using config t. Like that, I can use default instead of default -router. And then I would just name this as R3. And then go to interface FA0/0 and say no shutdown. And go to IP address. What IP address do we need to configure? The third network says 1.192. So 192 is going to be the network ID. The first usable IP address is going to be 192.168.1.193. Space the subnet mask is going to be 224/27, correct? And then I say IP DHCP pool C, and we say network 192.168.1.192. That's the third network ID along with the subnet mask 224. And then I say default hyphen router 192.168.1. I would use 193. Make sense? And that's gonna be R3's config. I'll also go ahead and configure R2. There you go. You get the IPs from second network over here, and then you will get them from third network on R3 species. And there you go. Then we will go ahead and configure the fourth network now. Say no enable conf t interface FA0/0 no shutdown IP address 192.168.1.225, and then the subnet mask is going to be 240. Cool. And I will also name that, I forgot to name that router as R4, and then I would again go to say IP DHCP pool D and say network 192.168.1.224 along with the subnet mask that's going to be 240, and then the default hyphen router 192.168.1.225. Cool. That's what the config is going to be. Make sense? And then I will go to the PCs over here, desktop and DHCP. And there you go. Over here as well. Good to you? So that's what the configuration will look like in Vlsm. Okay. So you can see that the networks that we used was from for the first network, that is sales department, we use a network that ranged from 1.0 to 1.127. That gives us 126 valid hosts, right? For second network for marketing, okay, we had a we used from 1.128 to 1.191, right? That gave you around 62 valid hosts. For third network for HR, we use from 1.192 to 1.223. That gave you around 30 valid hosts. And for fourth network for admin, we use 1.224 to 1.239. That gave you around 14 valid hosts. So that's what the config really looked like. Okay. So you can take the screenshot of this particular screen over here and do configure or do try to configure this network whenever you get time today. Cool. And we will continue with serial configurations with the remaining IP addresses that we have. We still have 16 valid IP addresses with us, right? From 240, because we ended up at 239, and from 240 to 255, we still have those IP addresses. Make sense to you? Yeah, you can check the CLI of R4. You see that? First we went into enable, then we say conf t, then go to interface, and no shutdown, and then IP address 225, and then we renamed that, and then we again continued with I would say configuring DHCP pool, then network space this command, and then default hyphen router. That's what we did, and that's all that we actually had to discuss today. Okay, we will continue with the subnetting and VLSN journey today, tomorrow, and we'll see how it goes further. Okay, I'll see you guys tomorrow. Thank you so much for tuning in today. I hope you had a wonderful session, and I'll see you guys tomorrow. Take care of yourself. Bye bye.